In our last video, we were looking at how to get the kth largest element, and we saw various methods of doing that. One is by creating a min heap, the other one was the quick select method. Now, what we are going to look at is counting sort. What is counting sort? Say, for example, we have an array 1, minus 1, 3, minus 3, 7, 4, 5. What do we need here? We need the kth largest element. What is k? So, for example, if k is 2, then 5 would be your answer. It is the second largest element. If k is 4, then 3 would be your answer because 3 is the fourth largest element. Right? In counting sort, what do? Is we create a new array. I have named this array as count. And if minus 3, so from minus 3 to 7, so the minimum value that we have in this array is minus 3, and the maximum value we have is 7. So totally in between there are totally 11 spaces that we need. So say if we now take an array of 11 spaces, minus 3 is the first one and 7 is the last one. So here I'm going to fill in how many times minus 3 occurs in the given array. Here I will fill in how many times minus 2 occurs. Here I will fill in how many times minus 1 occurs. Here I will fill in how many times 0 occurs. Here I will fill in how many times 1 occurs. Here I will fill in how many times 2 occurs, and so on and so forth. So minus is, so 0 corresponds to minus 3 and 10 corresponds to 7. Now what we are going to do is we are going to go through the array, and we will keep updating the frequency in the right space. So for example, if there are multiple minus 3s, we will keep updating the frequency in this spot. If there are multiple 7s, then we will keep updating the frequency in this spot. So let's go through the array. Okay, so the first value is 1. Where should we fill in the frequency of 1? In position 4. Why? This corresponds to minus 3, this to minus 2, this to minus 1, this to 0, and this to 1. Right? So, at this position, we will update the frequency of 1. The next element that we have is minus 1. Where should minus 1 go? Here, because this is minus 3, minus 2, and minus 1. So we update the frequency here. The next element we have is 3. Where will 3 go? Minus 3, minus 2, minus 1, 0, 1, 2, 3. So we've updated the frequency to 1 here, right? The next element that we have is minus 3. Minus 3 is the first element, so we update the frequency here. Then we have 7. 7 is the last element, so we've updated the frequency here. Okay. What about the next element? Next element is 4. Where should 4 go? Minus 3 minus, there's minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. So here at this position, we've updated the frequency of 4. And now the frequency of 5 we update here, right? So we have updated all the frequencies. And so now this is basically our solution. What do? Our first The first thing that we do is we take the min value and the max value. Okay. Why do we need the min value and the max value? So we go through the first array, the array that's given to us, and we go through the min value and the max value. Once we've got the min value and the max value, we know what will be the size of this new array, right? That will be the max value minus min value plus 1. And after we've done that, what do? We are going to update the count array. How do we do that? Now, whatever the value of num is minus min value, right? So if our value, for example, is 4, and 4, what is the min value? Min value is 3 minus 3. So 4 minus of minus 3 is position 7. So 4 is gets updated in position 7. Okay. Similarly for 5, where does 5 get updated? 5 gets updated in this value 5. And what is the min value? Minus 3. 5 minus of minus 3, that's 8. So at 8 is where I update the frequency of 5. Similarly, if I had to update 7, so what is our min value? What is the starting value? Minus 3. So 7 minus of minus 3 is 10. So at 10th position, we are updating the value of the frequency of 7, right? So basically from the current value we subtract the main value, because we are not starting from 0. Had we started the array from 0, then this is what we would have updated for 7. But because we are starting it from -3, we move that by 3 positions, right? So 7 minus of -3, and that's how we get the position at which we have to update the frequency of 7. So after the first loop is where we get the min value and max value. We go through nums and we find the min value and max value. In the second loop, what do? We initiate the count array by going through each of the values in each of the num in this array. Each of these elements in the array we go through. So here we've named array as nums. Okay, so we go through each of the element in this nums array, and we update the count array. Okay, now what do? Now what we need is the kth element. Okay, let's look at how this works. So for example, now, say for example we need the fourth element from the end. So at this point at the beginning, remain is 4. Okay, so we still have 4 elements to go through to get the fourth largest. We'll go through this from the back. Here we have at position 10 we've encountered 1, so we've come across the first largest element. Okay, and we subtract that from remain. So now we have to go through 3 more to find the fourth largest element. Okay, now what do? Now we come here, and when we come here we subtract another one. Okay, and now we have 2 more elements to go to, because now at this point when we subtract another one, remain becomes 2. Okay, now and we run this loop till remain is less than or equal to 0. And I will tell you about why we are considering even less than equal to 0 and not just equal to 0. I'll come to that. But next we go on to the next element, 7. At 7 we subtract one more element from remain. Now the value of remain becomes 1. Okay, now at 6 we subtract one more element from remain. So what does 6 remain become? Remain at this point becomes 0. Okay, we've subtracted 4 from remain. The remain was initially initiated as 4, because k is the fourth largest number that we are looking for. So at this point when we reach 6 is when k becomes 0. So what do we return when k becomes 0? What we are supposed to return is what is this value. Like 6 is not the value we are representing with 6, right? What is the value that we are representing? We are representing 6 plus the minimum value. So at position 6 we actually have the frequency of 3, which is 6 plus -3, which is 3, right? So because we started from -3, this was -3, -2, -1, 0, 1, 2, 3. So at position 6 we are actually representing the frequency of 3. So 3 should be the fourth largest element, and that's what we return. Now why are we considering remain less than equal to 0 and not just equal to 0? That is because what if we had multiple sevens? What if we had multiple sixes? Okay, so for example, if we had multiple threes only, for that matter, when you'd come here, say you'd subtract one from remain, here remain would become 3, then again one, subtract another one from remain would become 2, and here you've subtracted another one from remain and remain becomes 1. But at this point you have multiple values here. Instead of 1 you would have a 3, for example, or 2, for example. At this point remain would become -1. But we are not bothered about that. Even if it becomes less than 0, we know at before this point it wasn't 0, remain wasn't 0. At this point is where remain became 0. So 6 has to be the answer, or rather whatever value 6 is representing has to be the answer, which is why we do a less than equal to 0. And we also have a condition here where we return -1, but this part of the code is never going to be reached. We had to return something. The code had to return something because we have specified that it has a int return value. In all cases, it will get returned from here. But because the function had to have a return, we've returned a -1 here. That is it. Thank you.